Good morning, students. In this class, we are going to study about the power flow diagram of DC generator. So before moving to the power flows or power stages in a DC generator, we want to know what are the inputs and outputs of a DC generator. We already know that the input of a DC generator is always mechanical energy and the output of the DC generator is always electrical energy. So, in between these two stages, that is in between this input and the output stages, there will be some losses occurring. We already discussed in the previous class that what are the different losses occurring in a DC generator. So, we know that the losses occurring in DC generators are mainly constant loss and variable loss, or we can call it as iron loss and copper losses. So, we can say that in this power flow diagram, you can see that the electrical you can see in this one that the electrical output will be produced in this DC generator and our input will be mechanical supply, right? So the primer over output, that is we will be calling it as the mechanical power input that is given to the DC generator as the input, and from that you can see that there will be some iron and frictional losses occurring in the DC generator because of this mechanical part. We already told that the mechanical losses are mainly windage loss and frictional losses, and also the constant loss iron loss, that is hysteresis and eddy current loss also occurring in this machine. So that loss will be there, and from there you can see the next stage, that is electrical power generated in the armature, that we already derived as EG. EG is the electrical EMF generated, and electrical power generated in the armature we call it as EG into IA. And next from there will be some copper losses. We already discussed the variable losses as copper losses, especially that is occurring in the armature windings, especially series field winding and shunt field windings, and also interpole in between these interpole windings. Especially all these are copper losses occurring in the winding, I square R losses. So that also we can minus, and apart after reducing these losses we will be getting the exact electrical output. So from this input there will be some stages in between where losses are occurring, that are mainly constant losses and variable losses. Constant losses are mainly known as iron and frictional losses, and variable losses are copper losses. So A, B, C are the different stages in a power flow diagram of DC generator. Then we can see that if we are minusing, that is A minus B will be equal to iron and frictional losses, and similarly B minus C will be equal to our copper losses. From this diagram you can easily visibilities, that is you can see this iron losses can be deducted from the input to get the electrical output generated, and if we are minusing this copper loss from this electrical generated output EG into IA, we will be getting the external electrical output power, that is C. So from these equations we can write the from these are the losses, that is constant loss and variable loss. From this we can write the equation for mechanical efficiency, that we will be calling it as Ym for mechanical efficiency. So mechanical efficiency, normally this is our mechanical input, right? So mechanical output, this is the electrical output. So the mechanical efficiency is, we will be calling it as B by A. B by A will be calling as the mechanical efficiency, that is mechanical input and mechanical electrical output. So electrical output divided by mechanical input will be giving the mechanical efficiency, that is mechanical efficiency is equal to B by A, where B is the EG into IA, that is electrical power generated in the armature divided by the mechanical power input, is known as the mechanical efficiency. Then what is the electrical efficiency? This is our electrical input and this is our electrical output. So electrical efficiency is nothing but it is C by B. because both are electrical, right? Electrical input divided by electrical output, will be calling it as electrical efficiency. That we will be calling it as, that will be occurring here, this because these are electrical part and these are mechanical part. So this electrical efficiency will be, output will be C and input will be B. So C is equal to, we already know that this is the output generated at the load, that we already derived as V into IL, load current into load voltage, and mechanical electrical input generated EG is, I mean, PG is equal to EG into IA, right? So what will be the electrical output or electrical efficiency? Electrical efficiency is equal to V into IL divided by EG into IA. You can write like that, right? V into IL divided by EG into IA will be our electrical efficiency. Then what will be the overall efficiency, or we can call it as commercial efficiency? It is equal to general output by general input. That is, our actual output is C and our actual input is A. So the commercial or overall efficiency is equal to C by A, where C is equal to, what is C? This is our overall efficiency. C is equal to V into IL divided by, what is our input? Mechanical input, right? So we can call it as mechanical input. This is our overall efficiency. So this is the power flow diagram of a DC generator. If it is asked for the exam, you should draw this diagram very neatly and you have to mention three efficiencies. One is mechanical efficiency, and the second one is electrical efficiency, and the third one is overall efficiency or commercial efficiency. Thank you.